Okay, algebra. We are doing lesson 6-7 today, writing linear functions. We are going to be using slope to write a linear function. So this is the slope-intercept form we've been talking about, where the m is the slope and the b is the y-intercept. So the information needed to write the equation of a linear function can be provided in different ways, including presented as a graph, given as a description of a relationship, or as input-output pairs. So pretty self-explanatory. A graph would be a coordinate plane, a graph of a linear function, a line. A description of a relationship might just be a wording of a description, or it could possibly be maybe a rule that they provide for you. And an input-output of pairs would be something like an XY chart like this, or we've been learning the different notation for it. So it might be an X and then a f of X, which is the same thing as the Y output. So let's just start with example number 1. And it reads, write an equation for the linear function f of x whose graph has a slope of 3 and a y-intercept of -1. So again, here is the formula that we are trying to make for this linear function. And they literally tell us the numbers. They say that the slope is 3 and the y-intercept is -1. So for the m, the slope, I'm going to substitute the number 3. And for the y-intercept, I am going to substitute the number -1. So the y value is always going to be equal to 3 times the x value. And then this is a plus a -1. So if you were talking about the y-intercept, where would this cross the y-axis? It would be at -1. This might be written as y equals 3x minus 1. So again, it's going to be this -1 if you were going to graph it. So let's just go through the function notation, just the difference of the function notation. All they've done is they've replaced the y with the function notation f of x right here. Other than that, our equations are equivalent. Let's reflect. How can you use the equation f of x equals 3x minus 1 to find more ordered pairs that are part of the function? So ordered pairs that are part of the function are xy pairs that are solutions to the rule, or solutions to the equation also. So we've talked about this before. We can just choose x values and plug them in to find our related y value. So for example, if I was going to choose a negative number, I would choose an easy one, -1. I would put it into the equation and I would put in f of -1 equals 3 times -1 minus 1. So my solution, or my output, would be f of -1 is 3 times -1 and then minus 1. So if I was to solve this, I'd do this first, and then I can see that my f of -1 equals -4. So when I plugged in -1 for the x value, my output f of x, when I do f of -1, is -4. Just to do a really easy one, let's plug in 0. When you plug in 0, you should get the y-intercept, so let's plug in 0. So f of 0 is 3 times 0 minus 1. So f of 0, when we plug in 0, we get 0 minus 1. So the f of 0 is -1, which is our output of -1. So that's how you find other ordered pairs. We could plug in any numbers we want. We could plug in really large numbers. We could plug in some positive numbers, negative numbers, and then just make our graph. So all of these are solutions or part of the function. Now, down to the your terms at the bottom, these first your terms are simply substitutions. So again, we're trying to substitute into y equals mx plus b. And for number 2, 3, 4, and 5, they literally give us the m and the b. So for number 2, we're going to write y is always equal to, the slope is 4, times the x, and then minus 2. Again, that could be plus a negative 2, but this is the form it's going to be written in. Number 3, slope of negative 3 and an intercept of 5. So the y value is always equal to the slope times the x value, and the intercept is at 5, positive 5. Number 4, the y value equals slope is 6 times my x, and then there's an intercept of 0. So I would start with that, but then my final answer, I would just eliminate the 0 since 0 is 0. And this would be my final answer for that one. There's nothing wrong with this one up here, but it's going to be simplified to this one down here in the box. Number 5, the y value is always going to be, the slope is 0 times my x with my intercept of 6. Again, this is correct, but 0 times any value of x is just going to give me my 6. So it would be simplified to y is 6. So this down here in this box is what the answer would be if I was going to write a final simplified answer. Okay, let's move on to example number 2, the next page. So now they aren't just giving us the information so easily. They give us a table of values, again, the x and the f of x. The f of x might as well just be the y value. That's the same thing. So it's still like an xy chart. The table shows several ordered pairs for the linear function f of x. Write an equation for f of x. So they're telling us it's linear. So we don't need to check to see that it's going to be linear. It is linear. So we can choose any 2 points we want to find the slope. They don't just say m equals. So we need to use what we know about slope to find a slope. Now they've chosen some points down here. We're going to choose some different points. So let me see. They chose the first 2. So let's choose the second 2. So over here, I'm going to do my slope formula. Okay, this should be in your head by now. And I said I was going to use these second 2. So I was going to use this point and this point. So I'm going to call this my first x value and my first y value. I'm going to call this my second x value and this my second y value. So when I substitute these into my formula over here, step 1 is to find the slope. So step 1 is find the slope. Step 1. So I'm going to substitute my second points in here. I'm going to do m equals, my y2 is negative 11, subtract, because the formula says to subtract, my y1 value, which is negative 3, over my second point's x value, which is 7. I'm going to subtract, because the formula says to subtract, my first point's x value, which is 3. So when I simplify this, I get negative 11 plus 3, negative 8 over 7 minus 3 is 4. And when I simplify this, I should get negative 2 over 1, which is what they got over here, which is a slope of negative 2. Now, the second step is to substitute now what you have. Now you need to do step 2. You need to find the b, or find the y-intercept. So now you have this formula. So this is part of step 2. Using this formula, we're going to substitute values that we now have into this formula over here. This formula has 4 variables at this point: y, m, x, and b. If we can find 3 of these variables, we can solve for the 4th. So we have the m, we just found it in step 1, and then we have 3 choices for the x and the y. We could use point number 1, point number 2, or point number 3. It doesn't matter which point. So since I haven't used this top point yet, I'm going to use this point for my x and my y, and then we're going to use our -2 from our slope from our step number 1. So literally substituting these numbers into this formula. The y value is going to be substituted with a 5. The slope is going to be substituted with our -2. The accompanying x value for this y value of a 5 is a -1. So I substitute that in, and what we need to solve for is what our y-intercept would be. So now we just do the math. We have 5 is, following the order of operations, 2 plus b. Solve this equation for the b, and we get 3 is equal to our b. Now they got the same thing over here using different points. So the y-intercept is 3. So finally we can say the formula y equals mx plus b is the y value is always equal to our slope plus our intercept. So this is the equation. It's the exact same thing as theirs. Again, they've used the function notation f of x, same thing as a y. So now let's reflect. Number 6, how can you check that the equation is correct? For this equation to be correct, it has to be a true statement when you plug in these points up here. So we solved it using this first point, so I'm fairly sure it will work for this one. So I'm going to just choose this point right here. So the answer to this would be plug in points and values should be equal. So again, let's try this. Let's do y equals -2x plus 3. And I said I was going to choose this point, 3 comma -3. So wherever I see an x in my formula, I'm going to substitute 3. And wherever I see the y, I'm going to substitute the -3. So down here I'm going to say -3 is -2 times 3 plus 3. -3 is equal to -6 plus 3 is -3. Is this a true statement? Do these values equal each other? Does -3 equal -3? Yes, it checks. So that means that this point, 3 comma -3, is a solution to my equation. So if they are solutions, it means that the equation is correct. Now, move on to your turn. Try these 2 on your own, and I will come back and show you the correct answers and then show you how I solved those. All right. So for these your turns on page 202, here's number 7 right here. So again, following the same criteria and the steps, I would find the slope, and then my second step would be to find the b, or find the y-intercept. So for number 7, I used 2 of the points. I did 16 minus 6, 3 minus 1, 10 over 2, so I got my slope is 5. And then my second step, I used the slope I just found, which is 5, and I chose one of the points. It doesn't matter which point, it's not a magical point. I chose 1 comma 6. So in my formula, y equals mx plus b, I substituted the 3 values that I knew. I have an x, a y, and an m. I substituted them in and I solved for my b. So I could say that my equation was y equals 5x plus 1. Okay, the same work I would do for number 8. So let me plug that in down here. Y equals 5x plus 1. So I did the same steps for number 8. I chose 2 of the points. I used the slope formula, and I found out my slope was -2. For the step number 2, I used my slope I just found in step number 1. One of my points, -1, 1, and I substituted the 3 values I knew and solved for my 4th variable that I did not know. And at the end, I can tell you an equation that will always hold true for any y and any x. The equation would be y equals -2x minus 1. Down there. Okay? So now, moving on to using our linear function in a real life situation. So example number 3, the graph below shows the increase in pressure measured in pounds per square inch as a scuba diver descends from a depth of 10 feet to a depth of 30 feet. Pressure is a linear function of depth. At the water's surface, the pressure on the diver is a result of the pressure of the air in the atmosphere. What is the pressure on the diver at the water's surface? So first they kind of talk you through what the paragraph is even talking about. We go over here and we look over at our graph, and we see that it's only in quadrant number 1. They are doing the x-axis. They have depth in feet. So this is their depth in feet along here. And then on their y-axis, they've put the pressure in pounds per square inch. Okay? So they're saying, let P of D represent the pressure in pounds per square inch on the diver at a depth of D feet. So they're saying, let the y, the pressure, be in relation to the depth of D feet. It's depending on the depth. So this y-axis depends on how deep you are. At the water's surface, D equals 0. So the D equals 0 would be right here. If the graph below is extended to meet the vertical axis, the value P of 0 would represent the pressure on the diver at the water's surface. So what they're saying is, if this is a linear function right here, if we extended this in a straight line, that would give us what the pressure would be at a depth of 0. So first they want you to find an equation for this linear function. They've given us 2 points, so we're going to follow the same steps that we did in our previous examples. So over here, let me follow those same steps. So step number 1, find the slope. Okay, now I'm going to do m equals. Now I'm going to do it in the same order that they did just to make things easier for us. They said that they took 28.0, subtracted this point's y value. And since they started with this point, this is the second point that they're going to start with, the x2, so 30 minus 10. Now they solved this, and they got 8.9 over 20. And when you do this math, you get a slope of 0.445. So we're not used to getting decimal slopes. This decimal is close to 0.5, which is going to be close to 1/2, which is going to be about up 1 over 2, up 1 over 2. So just to give you an idea, that would be close to 1/2. So you can see just from our graph that it goes up 1 over 2, up 1 over 2 approximately. But again, you have to pay attention to the units that they're doing. These are not exact. They're not exactly the same. Down here, each little grid line is worth 5. They're counting by 5s. And on the y-axis, each little grid line is counting by 4s. So if I was going to actually count my slope from this, it would not be a direct correlation of up 1 over 2. Also, pay attention to the fact that they are using decimals. They're calling this 28.0 exactly, and down here they're calling it 19.1 exactly. So to count my slope from this graph would not be an easy task. So you are going to want to use this slope formula because it's not going to be exactly 0.5. It's close to 0.5, but it's not exact. So we found the exact slope. Now let's do step 2. Find the y-intercept. And we're going to do this by plugging into our formula. Y equals mx plus b. Okay, so we are going to use the same points that they chose. They chose the 10, 19.1. So they substituted the y value, 19.1. equals the slope, we just figured it out, 0.445, times 10 plus b. And then they solved 19.1 is 4.45 plus b. They subtracted 4.45 from both sides. And then they get that the b is approximately 14.7. So we have a slope that is always 0.445, and we have an intercept, that is approximately 14.7. So now this is our equation that is always true. And the second question that they wanted us to find was, if I go back to their problem, what is the pressure on the diver at the water's surface? So we had to find the equation to answer this question. Well, the diver's depth at the water's surface is 0. So we go back down to our equation, which we found right here. And this value right here is the x-axis value, which is the depth. So if this was 0, what would the y value be? You can quickly see that if we substituted 0 in here, this would make this whole term 0. So you'd be left with y is 14.7. So the pressure on the diver at a depth of 0 is 14.7, and then the units would be pounds per square inch. Okay? Now, your turn back here on page 204. The simple way to do this problem would be to just read the numbers off of the graph. So the simple way, y equals mx plus b, I can count my slope. If I count from a perfect point to another perfect point, I would go up 1, which would be positive 1, and then to the right 2, which is positive 2. So the rise over the run would be 1 over 2. So my y is 1/2 x. And then where does it cross my y-axis? What is my y-intercept? I can read between -2 and -4. At that grid line would be -3. So it crosses my axis at -3. Now you can solve this problem using the same steps that we did in our last example. Step 1 would be solve this for slope. Choose any 2 points and then plug it into this formula. Okay, but given this graph, I would choose this option. This way would yield the same answer. You would still get the slope is 1/2 and the y-intercept is -3. All right, good luck.